Assalamu alaikum. This is the third chapter I want to start today. Um, it's related to, it's on protective relay evolutions. Now, in the first chapter, it's an introduction. In the second chapter, I tackle the voltage and current transformer. In the third chapter, I will just to focus on the relays, okay, which are the three elements of a protection system. So, and then the fourth element is the circuit breakers, okay. So on the protective relay, in this chapter, I want to see the evolution, how the relay developed from the electromechanical type until the latest type, which is built on microprocessor, which we call them numerical relays. So like I will cover a history, constructions of these relays, okay? But we will not go in details how we will use them, how we will set them, okay? But only how they operate, their constructions, okay? So I'll try to first start with classification of relays. The relay standards of numerical numbers, and already covered this in the previous introduction chapters. Relay technology evolution, I'll start with the electromechanical and static relays, then I'll cover then lastly microprocessor relays. In relay classification, we can classify relays based on the inputs, okay, to that relay. We have overcurrent relays where the input is a current, okay. We have directional overcurrent relay where the input is voltage and currents. We have distance relay where the input voltage and current to measure the impedance. We have over voltage and under voltage relays where the input is voltage. We have differential relays which compares a set of inputs and output currents, okay? We have reverse power relay where I need voltage and currents. We have under frequency relay. So these are detecting where in under frequency I want to measure the frequency, but based on input voltage measurements, okay? So what's the frequency of that voltage, okay? So based on which I want to take a decision. Is this low frequency? If it's low frequency, then nominal, then what action I want to take. So this is based on the function, okay, protection function it carries. We can also classify relays based on the relay rule within a protection scheme, okay. A relay could be a protective relay, like what I mentioned, over current, distance, or under voltage, under frequency relays. These are protective relays, okay, where it needs a CT or VT as input. Based on monitoring this current, it decides is this an overcurrent or not, or normal operating current, okay. And if it's a fault current, then relay close its contacts to tell the circuit breaker that it detects a fault. So we have other relays, we call them auxiliary relays, where the auxiliary relays, we have different types of auxiliary relays, but their purpose is contact multiplication. If the main relay, protective relay, has one contact, I can create more output contacts from this contacts using an auxiliary relay. I can have a flag indication. I can, how do you know this relay has tripped or not? There will be another relay within that device, okay, within the protective relay, just to show you that it has tripped, okay, as a flag. We can use this to also introduce time delay. I can use to trip two breakers at the same time. So we have multiple outputs from just one contacts here. So suppose now I have a fault. Suppose I have a fault here. Now the breaker is closed, and I have a fault here. there will be high current flow here. Then that current corresponds to high current here. The relay will declare that is a fault, so it will close this breaker. Its contact, sorry. And once this contact is closed, so the auxiliary relay coil, which is this coil, is energized. Once it's energized, it has a set of contacts. Some of them is normally open, like the top one is normally open. At normal, if this is de-energized, these contacts are open. While some of them is like this one is normally closed in C. These two contacts are closed when this coil is de-energized. Now, once this coil energized, this status will change. The normally open becomes closed, and the normally closed will be opened. Okay, so when there is a fault, this will see relay will detect this a fault. It will close its contacts, and this relay will be energized because I have a DC source here with this. So this will be energized. Once energized, it will change the normally open contacts to closed. And once this is closed, the circuit breaker has a trip coil. It's already also connected to a DC supply. So once this is closed, the trip coil of the circuit breaker will get energized. Once it energizes, if it is closed, it becomes open. Okay. So this will becomes open once trip coil of the circuit breaker is energized. And I can use also the other contacts here. Once they are closed, I can show, I can trip another circuit breaker, or I can show an alarm or a lamp. This has tripped, or okay, I can have a flag that this relay has tripped. So we have several contacts I have here to utilize for different functions. Okay. So this is called auxiliary relay. It's not a protective relay. It looks something like a contactors. We have other relays. It's not a protective, but we call them monitoring relays. Okay. We have regulating relays. We have reclosing relays. We have synchronizing relays. Synchronizing relays is a relay now. Its purpose is not a protection now. If you want to, suppose I have a bus bar, okay, it's connected to a generator number 1, okay, and now I want to connect a new generator to the system. Now, to close this, I have to make sure the voltage here at this point and this point is same as the bus voltage, same frequency, same phase shift, okay, same angle. Before, this is the condition for synchronizing a voltage generator to the system. So a synchronizing relay can check. If you want to close this breaker and the voltages are not synchronized, then of different frequency, it will not allow you to close this. Okay. So this is a synchronizing relay. So it can automatically also, you can allow it to automatically monitor this voltage. It increases the speed of the turbine until the frequency is same. It also monitor, it's check the excitation, vary the excess so that this voltage becomes same as this. Okay, and try to make the conditions of synchronization satisfied, and it closes. So these are not a protective relay, that we call them synchronizing relay. We have relays that regulate regulating relay. Like if I have a transformer and I have a tape changer, a tabs here, different tabs, and the tape changer, this can be connected to this tab, or this can be connected to this or that. So I can change the ratio. I want to regulate this voltage to be same, equal. Now a relay will measure will measure this voltage, V secondary, and I want to make V secondary is, let's say, 11 kV, regardless of variation in the primary. So what it really, it measure this and compare it with 11. If the voltage is, if this voltage higher than 11, you want to readjust the tap so that this becomes 11 kV. And this is called regulating relays. So the relay that change the tape changer taps is a regulating relay, okay? We have monitoring relays that monitors, let's say maybe it monitors the flow and power lines, okay? So we have monitoring relays, not purpose is to protect a system. And we have also reclosing relays, okay, where sometimes if we have three-phase system and each phase has a breaker, and suppose now we have one bird or whatever, or in not a permanent fault. A fault occurs here, but it is intermittent faults. And this intermittent fault occurs, so we want to open this, the faulty phase, and you reclose it again after a time delay. So the relay that reclose this, okay, is, we call it reclosing relay, okay. So once the protective relay detects this force, it gives a command to this phase to trip, and it's only trip one phase in this case. It's called single phase tripping, reclosing, okay, or tripping. So it will open the faulty phase. If this is a permanent fault, and once you reclose it, the fault current will occur again, and the protective relay will not allow the reclosing relay to reclose again, okay. I can allow this. So they have different types of relays, okay, other than protective relays. But in this course, my objective to focus on only protective relays, okay? I will not cover these types of relays. Relays also can be given identification number, right? So each, like distance relay is 21, overcurrent relay, instantaneous overcurrent is 50. This is what I'll cover in one chapter. This I'll cover also in the same chapter. Circuit breaker is given a code 52. A differential relay I will cover it in another chapter. Okay. I'll have directional overcurrent I will cover it in another chapter. Okay. So I'll cover these things inshallah in the following chapters. And these are standards as per IEEE 3C37.2. This is according to American standard. British standards or the IEC standards also they give relays with symbols, right? So for instantaneous overcurrent relays, so it is given as a box like this with current I and double greater. Greater than means overcurrent, and double greater is instantaneous. Okay. So this is the symbols. Okay. According to IEC, the symbols according to IEEE. And you don't have to memorize these now. So this is the relay identification. We can also classify relays based on, now it used to be like in old technology, each of these is a separate relays, okay? But in numerical relay, we can combine those functions all in one relay, okay? So I can have maybe 10 or 30 functions, protection functions in one relay, okay? There is another classification of relays based on the technology. Like here I have electromechanical relays, which is based on electromagnetic principles. And we have static relays based on, and we have the third one is numerical relays. Okay, the third. So these are the three classification based on relay technology. Okay, or we can say this is the first generations of relay, second generation of relay, the third generations. Like in communication, we have G1, G2, G3. Now we are in the fifth generation of communication. Okay. Now relay is also relay can be classified like based on their technology as in electromechanical relays. They are mostly a hardware, right? You have a core, you have coil, you have magnetic fields, a disk that moves like a motor. Okay. This is what I meant about this is an auxiliary relay. This is the protective relay. This is an auxiliary relay. This auxiliary relay just has an indication where you want to see if this is tripped or not. So this is an example of auxiliary relay with another. This is a protective relay. Okay. Now this is based on electromechanical principle. You have this is established from 1900s, long technology based on electromechanical principles. You based on attractive forces or rotational torques. Okay, this is the principle of operation. While in static relays like the solid state or relays, we are the first generation was on using analog electronics in 1960s. Then when we have comparators and digital logics, we use digital electronics in 1970s. So all of this was also a hardware. Okay, so when I say static, a relay has no moving parts. Okay, like this. This has this lever moves. Okay, and this is also this disc moves. So in these we have no moving bars like in these two technology. So we call them static in general relays. And the static relays, the old technology based on let's say this, op-amps or based on diodes, rectifiers. Okay, we have also as a hardware. There is no software. But the new technology now, which is based on relays built based on microprocessors, we have, which is what established in 1980s. Okay, the microprocessor-based relays. Now we have a hardware plus a software. Software, now it can implement it using microprocessors or using digital signal processing boards. Okay. So now these protection functions that I mentioned here now is not a hardware, just what's inside this box is also a software to implement the overcurrent or the distance. How do you measure distance Z? So I have to measure the currents, I have to measure numerically, okay, by using digital signal processing, okay, instead of hardware measurements. There is an evolution on relay technology, like 1900, the conventional protection was overcurrent. Overcurrent was established in 1901, then differential in 1908, directional relays in 1910, distance in 1923. No, and these are the these technology where these distance relays, I mean, protective relays is invented, time at which it is invented. So in 1970s, we have computers was established, and we want to utilize them for relays application, for protection application. So we can use traveling waves in 1970s, adaptive relays. Okay, we have artificial intelligence in 1990s. And then we have when GBS also there, we can use GVS, okay, as an input to a relay where I can now compare two signals on same time, with respect to the same time frame. So we have wide area protection, okay, transient-based relays, and this is where the evolution in relay technology. This is a new development. All right. Inshallah, in the next class, I will stop here. In the next class, I will elaborate more on each technology. Okay. I'll stop my presentations here.